Welcome to this explainer. Look, if you've been watching the markets lately, you might be feeling a very familiar sting. Did you miss out on AI? Did you miss out on NVIDIA? Today, we're uncovering the absolute next technology race that investors are watching, a massive seismic shift that is currently capturing billions of dollars from tech giants, venture capitalists, and even national governments.
To figure out where we're going, we really have to look at where we've been. There's a very clear historical rhythm to these major tech booms. In the 1990s, the world-changing revolution was obviously the internet. In the 2010s, it was the massive shift to cloud computing. And right now, in the 2020s, it's artificial intelligence and semiconductor stocks, led, of course, most famously by NVIDIA. Let's be honest, a lot of folks look at this timeline and just feel this huge wave of regret. They feel like they totally missed those golden opportunities to get in on the ground floor.
But here's the thing. Instead of looking backward with regret, we need to be looking forward. So, the million-dollar question, or maybe the trillion-dollar question, is what could be the next major technology wave? What actually comes after AI? The answer, and the absolute frontier that is aggressively attracting those billions in capital from VCs all the way to the national defense sector, is quantum computing.
Section 1. Understanding quantum computing. Bits versus qubits. Let's dive right in.
Now, to understand quantum computing, you absolutely don't need a PhD in physics. Just look at the left side here. That's a classical computer. It uses bits. Every single digital thing you interact with today uses bits, and each bit is an absolute state. It's either a 0 or it's a 1. It's exactly like a coin resting flat on a table. It's either heads or it's tails. But on the right side, we have the quantum computer, and this uses qubits. A qubit can be a 0, a 1, or, and this is the crazy part, it can be both at the exact same time. Think of that same coin, but now it's spinning. A normal computer just sees heads or tails. A quantum computer basically sees the coin spinning in real time.
And that spinning coin analogy really brings us to the core concepts of quantum computing. And I promise, we're doing this without a single complex equation. First up is superposition. That's the ability of the qubit to exist in multiple states at once, just like our spinning coin. Then you have entanglement, where qubits become intrinsically linked together. Basically, what happens to one instantly affects another, no matter how far apart they physically are. It's wild. And finally, quantum interference, which is how the system effectively cancels out the wrong answers and amplifies the correct ones. Guys, these aren't just tech buzzwords. They are the literal mechanics of a totally new way to process information. By leveraging these three principles, a quantum computer doesn't have to test solutions one by one like your laptop does. It can process a vast ocean of possibilities simultaneously. And that unique ability is exactly why it's poised to tackle problems that are currently impossible to solve.
Moving on to Section 2. Why does it matter? Solving logistical nightmares.
Think about this for a second. Finding the absolute best delivery route for, say, 10 trucks on any given day. That's pretty easy for a classical computer. But finding the most efficient route for 10 million deliveries, that becomes an impossible logistical nightmare. The number of possible variations becomes so massively huge that a classical computer might literally take thousands of years to calculate it. But because of how qubits operate simultaneously, quantum computers are specifically designed to solve problems of this sheer scale dramatically faster.
And because it can solve those impossible math problems, the potential applications here are just staggering. We are not talking about minor software updates. We're talking about a fundamental reimagining of the physical world. If quantum computing scales successfully, it stands to completely revolutionize massive global industries. Imagine simulating complex molecular structures for rapid drug discovery, potentially curing diseases in months instead of decades. We're talking about engineering entirely new materials from scratch, building next-generation battery tech that could literally solve the global energy crisis. We just talked about logistics optimization, sure, but it will also completely disrupt financial modeling. It'll supercharge artificial intelligence far beyond what we're seeing today and totally reshape national defense and cybersecurity. The total addressable market here isn't just one niche sector, it's practically everything.
Section 3. The quantum technology race, or the early days of the automobile. I love this quote because to really grasp the current market, you have to realize that the industry hasn't decided which technology will win. This is so similar to the early days of automobiles. Steam, electric, and gasoline cars all competed. I really want to ground your expectations right here. This is a highly competitive, incredibly uncertain space. There isn't just one type of quantum computer being built right now. Look at this lineup. There are completely competing foundational approaches to building these machines. You've got massive tech giants like IBM and Google placing their huge bets on superconducting technology, alongside players like Rigetti. But over in the trapped ion corner, leaders include IonQ and Quantinium. Then you've got D-Wave forging ahead with annealing. PsiQuantum and Qubit are focused on photonics, which is using light. And Quera is pioneering neutral atoms. It's exactly like that steam versus gas versus electric car race of the early 1900s. We really do not yet know which of these underlying hardware approaches is going to become the ultimate, globally dominant standard.
All right, Section 4. How to analyze quantum stocks, the logical framework.
Okay, real talk. The biggest mistake most investors make when looking at emerging tech is that they only look at the stock charts. You have to pivot away from the hype. You need a logical framework to evaluate if a quantum company actually has the real-world fundamentals to survive long-term. So here are the 6 crucial metrics you need to watch. Number 1, cash. Can the company actually survive the years it's going to take to build this? Number 2, revenue growth. Is anyone actually paying for their early-stage technology today to prove there's real demand? Number 3, debt. Carrying way too much debt in an experimental phase is incredibly dangerous. Number 4, enterprise adoption. Are real Fortune 500 companies actively testing their systems? Number 5, patents. Who actually owns the core IP that will power the future? And finally, number 6, technology advantage. Do they have a clear, mathematically sound path to scaling up to millions of qubits?
Let's zoom in on that first metric, cash, because runway matters deeply in a sector that might take a decade to fully mature. When you look at estimated cash reserves, IonQ sits on billions in cash. Contrast that with competitors like QBST or RGTI, who have hundreds of millions. Having a massive cash reserve means a company can weather those long, highly expensive R&D storms without going bankrupt before the tech is even ready.
Section 5, Technology Assessment. Let's look at the current rankings.
Now, quick disclaimer right off the bat. I want to be incredibly clear that this is strictly a technological assessment based on current developments. It is not financial investment advice, okay? But when evaluating the leaders in the space based on their tech stack and progress, the current ranking looks like this. Number 1 is Quantinium. The reason they hold the top spot right now is their absolutely relentless progress in trapped ion technology. They've consistently achieved the highest quantum volume in the industry, backed by the industrial might of Honeywell, and they're hitting massive milestones in quantum error correction, which is basically the holy grail for making these machines reliable. Number 2 is IonQ. Also using trapped ion tech, IonQ has a distinct advantage, a massive cash runway. Like we just talked about, they have billions in the bank, giving them time to rapidly scale their algorithmic qubits. Plus, they are actively securing strong enterprise partnerships right now. Number 3 is D-Wave. They take a fundamentally different approach called quantum annealing. Now, while there's some debate in the physics community about whether annealing is a universal quantum computer, the fact remains that D-Wave systems are commercially available today. They're actively being used by corporations to solve highly specific, massive optimization problems. Number 4 is Rigetti. They're betting on superconducting qubits, kind of like IBM and Google. What sets Rigetti apart is their dedication to building their own in-house quantum foundries to manufacture their chips. However, they are facing much tighter cash constraints compared to the top players, making their journey a bit more perilous. And number 5 is Qubit, or Quantum Computing Inc. They're focused on photonics, using particles of light. Why does that matter? Because unlike superconducting computers that require massive absolute zero cooling systems, photonic chips can potentially operate at room temperature. This makes them significantly easier and cheaper to scale, even though their tech is still in its very early stages. So, these rankings reflect exactly where these companies stand today, based on their hardware achievements.
Section 6, the reality check. Understanding the risks.
Honestly, this might be the most absolutely crucial part of this whole explainer. A lot of creators just skip this part to pump the hype, but we won't. To balance out that immense excitement, you have to understand the harsh realities of this emerging sector. First, the revenue these companies are generating right now, it's tiny compared to their massive market valuations. Second, this technology may literally take decades to fully mature into what we envision. And because of that long timeline, some of these companies are absolutely going to fail completely. And finally, a clear, definitive winner may not emerge for many, many years.
This quote really hits the nail on the head. This sector could create the next NVIDIA. It could also create many bankruptcies. That is the absolute, unvarnished reality. You are looking at an incredible, world-shifting opportunity, paired side by side with the very real risk of total loss.
And finally, Section 7, Conclusion, the real mistake.
Let's circle back to that feeling we talked about at the very beginning, that stinging feeling of missing out on past tech booms. The biggest mistake investors make is not missing NVIDIA. The biggest mistake is believing there will never be another technology revolution. While the timeline is long and the risks are incredibly high, quantum computing's importance is already undeniable. It truly has all the hallmarks of being that next great revolution.
So the question isn't really if quantum computing is going to be important to our future. That's a given. The real question is, which company is actually going to turn this incredibly complex technology into a successful business? That is the billion-dollar puzzle we are all watching unfold right now. Thanks for hanging out with me for this explainer. Keep an eye on the tech, mind those risks, and never stop learning.